Lesson 2.1 Systems of Equations. Now we're going to start looking at dealing with more than one equation. And the reason we can deal with more than one equation is that if they have two of the same variables. So by definition, a system of equations is two or more equations that have the same variables. Now we're going to deal with two mainly, but you can also deal with three or four equations at the same time so long as they all have the same variables. In most cases we're dealing with x and y. Now solutions, when you have a system, come from different ways. And they are the values for variables that make an equation true. Alright, so in other words, if we have two equations, the point that works for both equations is considered a solution to the system. So let's take a look at a couple examples. Let's take a look at a graph. Okay, if I draw a line that goes like that, and I draw another line that goes like that, those two graphs intersect each other. These are intersecting lines. And that's important because they don't always intersect. I could also draw two lines that are parallel. So these two are considered parallel lines, lines that do not intersect. And then I could also draw a line like this and then draw one more over the top of it. So there's actually two lines, but they're exactly the same, so you cannot see the other one because they're exactly right on top of each other. And we have to consider each of these cases. Well, in the first case, the number of solutions when you have intersecting lines is their point of intersection. So one solution. If they're parallel, there is no solution because there's no point of intersection. And if they are the same line, then we have what's called many or infinite, which is the sideways 8, number of solutions because every point they touch. So every point is considered a solution. The description, same and different. Well, if you're looking at slopes, they have different slopes. So two lines that intersect have different slopes. And that allows you to know that they're going to intersect. And by the way, this point of intersection would be 1, 2, 3, up 1. So we would say over 3, up 1 is the solution to that system. For parallel lines, they have the same slope but different y-intercepts. If they have the same slope and the same y-intercept, that would be the last case here. They would look exactly the same. So they have to have different y-intercepts to be parallel. So again, for the same line, they have same slope and same y-intercept. Now with these situations, we have two other terms. If two lines intersect at one point, they're called consistent. So a system that has at least one solution, so they intersect at one point or they're the same line. So at least one means one solution or many. Inconsistent is when they have no solution. So in other words, parallel lines. So this is consistent, and one line over another is also consistent. Parallel lines are inconsistent. Alright, example 1. Without graphing, determine the number of solutions for each system and describe each system as consistent or inconsistent. Well, we talked about this in the previous slide. How do we know how many solutions there are? Well, let's look first of all at slopes. Same slope. So if they're the same slope, They're either going to be parallel or they're going to be the same line. The y-intercepts are different, so therefore it cannot be same lines. So if they have the same slope and different y-intercepts, then we're talking about being parallel, which means we have no solution. This is A. And B, we describe as consistent or inconsistent. Well, if there's no solution and they're parallel, it is inconsistent. Next problem. First one solved for y, so the slope is -1/2, but the second one's not solved, so we're going to have to do some work with that one. So just like in the last chapter, we're going to practice our solving for y ability. Divided by 2, and the whole side gets divided by 2, so I'm going to separate that, and I'm going to write -1/2 x plus, that'll be this part, and then I have to do this part. 10 divided by 2 is 5. So now we have a -1/2 and a -1/2. Same slope. Y-intercept is 5, y-intercept is 5. So now we're talking about having the same line, which means they have an infinite number of solutions. And that would be considered consistent. Let's solve by graphing. Now keep in mind, solving a system of equations by graphing is an approximation, and we need to know that because when we get to other forms of solving, that will change. So let's take a look at this one first. If we use what we've been working on in our last chapter, y-intercept is -1. Our slope is, I want to put the negative with the 3, so it's more obvious. So -3/4, so down 3, to the right 4. And we graph that line. Oops. Okay. Next one, we have a y-intercept 4, slope of 1/2, so up 1/2. We graph that line. Alright, so based on the graph, where's the solution? Well, it's going to be where they intersect. Now again, I've approximated this because my graph is not perfectly right. If I want to be exact, and we're going to try to find these things out, then I would start one point and do my slope. Up 1/2. That works. If I go the other way, it's down 1/2, down 1/2, down 1/2, and that's more specific. If we do the other line, it's down 3/4 or up 3/4, and that takes me to the same point there. So we can easily see now, in this case anyway, that the intersection point or the solution to the system is 1, 2, 3, 4, -4, and +2. That would be the solution for that one. All right, let's try the next one. This one has two equations. Both are not solved for y, so we're going to want to do that. So we will subtract x from both sides for the top one. And we'll get -4y equals -x plus 16. Divide by -4. So we get y equals -1/-4 is 1/4 x. 16 divided by -4 is -4. That's one equation. Next one, we get now -4y equals -x plus 4. Divide by -4. And y equals, again, +1/4 x minus 1. Alright, so let's graph them. The red line, we're going to go y-intercept of -4, slope of 1/4, up 1 to the right 4, down 1 to the left 4, just to make my points known. Go blue one, y-intercept, same slope. So these are not going to intersect because they're parallel. So we would say no solution. Now let's take a look at an applied question. We have Jake and Brad each opened their own savings account. Jake made an initial deposit of $200 and plans to deposit $20 a week. Brad did not make an initial deposit, but he puts in $60 a week. Alright, now this, we'll write two equations. We'll say M for money and W for work. So the money he makes comes from $200 initially put into the bank and $20 per week. And Brad's, same variables. He does not put any money in besides $60 a week. So let's sketch these two. Now you have to be clear about this. We'll put money on the left and we'll put weeks, in other words M, and weeks W on the bottom. Pretty big numbers here, so I'm going to jump to each one's going to be 20. It starts at 0, and it'll be 20, 40, 60, 80, 90, 100, 20, 40, 60, 80, 20, 40, 60, 80, whoops, I did that wrong. Glad I caught that. That wouldn't have been pretty. So 20, 40, 60, 80, 100. This is 100. 20, 40, 60, 80, 200. 20, 40, 60, 80, 300. And so on. The bottom will go by weeks, so 1, 2, 3, 7. We're wondering how long will it take them to have the same amount of money in the bank. So if we graph them, this is the y-intercept, so 200. And each week he puts in $20. So he starts at 200 and then a week later he's there, week later he's there, week later he's there, and so on, because he's putting in $20 a week. So that's his line. Alright, the other person, I actually got the colors backwards here, sorry about that. The other person does not put any money in right away, so they're here, but they put in $60 a week. So 20, 40, 60, here they are in 1 week. 20, 40, 60, week 2, 20, 40, 60, week 3, 20, 40, 60, week 4, 20, 40, 60, right there. Right, so we're looking at this point is where they start to meet. Alright, so right there they are the same. And how long does it take them? Sorry about that line, that was nasty. 5 weeks. 5 weeks for them to be in the same, have the same amount of money in the bank. This is a nasty line, I'm going to get rid of it. Alright, I believe that answered the last question. Alright, this ends lesson 2-1.